Hello everyone, it's Blogging here again after a while, and in this lesson I'll tell you how to convert or cast a value from one type to another and also why you might need it. But before that, I want you to know that I took a long break between recording lessons for personal reasons, and fortunately I can finally return to them. During this time my life has changed dramatically, but for you as well as for viewing my channel, the only thing that has changed is the font of code in Visual Studio. I decided to freshen up the look of the code a little and found a new font for myself. I hope you like it too, or at least find it readable. Let's get started. You'll already know that variables and literals contain values of different types. There are cases when you work with different data types simultaneously in one expression. For example, when you want to add 2.5 to 10. From previous lessons, you know that 10 is of type int and 2.5 is of type double, and when added, 10 will convert into type double. So this is also called typecasting, and it's divided into two types: implicit typecast and explicit typecast. Up to this point in time, all typecasts in our lessons were implicit. This means that their conversions are handled by the compiler when it looks at the code. I wrote several examples of implicit typecasting. In the first one, the number 100 in this expression will be converted to the double type. The compiler will do this for you. And in the second one, the number 65 will be converted to the char type to be written to the b variable. In the third one, -1 will be converted to the unsigned int type, and by the way, it'll be a completely different number because I remind you that the unsigned type can't have negative values. There will be no compiler error here. You can try to display this variable on the screen and see what value is stored there. Why this value is there? You'll find out when you watch my lessons in the future, where I'll tell you how values are stored in variables in bit representation. But you can also do explicit typecast. In this case, you specify in the code what type to cast the value or expression to. You may ask, why should I do this if the compiler handles it itself? I will answer this question a little later. Now let's see how we can do this. We have four options. The first option is that you write the type in regular parentheses. This method was already in the C language, and it's also available here. The second option is to write the type and then write the expression itself in parentheses. It works similarly. The third option is curly braces. It differs in that the compiler checks whether it's safe to cast one type to another. How can this be unsafe? For example, implicit typecasting is considered unsafe typecast because the compiler can truncate the value in the process. For example, if we write a number here that doesn't fit into the range of the char type, the compiler will still convert it to char, but will cut off several bits of information so that the value fits into this type. Similarly, you can create an integer variable and write a decimal value to it. You already know that the compiler will discard the fractional part. This is the whole insecurity. You may not immediately notice how the information is lost, and then you'll spend a long time looking for the place of the error. And when you do typecasting yourself, you kind of say to yourself, I know that the value can be cut off or changed, but I need it this way. Why do you need this? We'll see soon. So, in the third option, as I said, the compiler checks whether this cast is safe. If you cast a smaller data type to a larger one, then it's safe, because the information about the value isn't lost. All the bits of the value will be in place. And the last fourth option is to write such a long expression: static cast, type, value. There are four more keywords in C++: static cast, dynamic cast, const cast, and reinterpret cast. We'll have a separate lesson about each of them because they all involve typecasting, but they do it differently. Static cast in our regular examples does the same thing as the first two options, which is to simply cast one data type to another without checking the type safety. You can choose any option you like and use it. Many people recommend choosing the fourth option because it's easy to find in code. The first three options can get lost in complex expressions. Let's look at some examples. Imagine that you have two variables of type int. You can't change their type, but you need to divide one variable by the other. You have a result variable. You understand that division may result in a decimal value, but you also know that the division of int types can't result in a decimal value. The compiler won't convert int types to double on its own, only the result. So you have two options. Either you create two more variables of type double and copy your two values there before dividing, or you explicitly convert the values of the variables to type double during the division itself. I chose the second option here. The variables remained with their data types, but at least I got the exact division result. Note that it's not necessary to cast the types of two variables, only one is enough. And then the hierarchy of data types, which I talked about in the previous lessons, will work. Without explicit typecast, you wouldn't have solved this problem without creating a few more variables. The second example is that we need to display the index of a character on the screen. See how it displays character types showing characters, not their indices. So to display the index, you can, again, create a new variable of type int and copy yours there, or explicitly cast the char type to type int when displaying the value. Here, we'll see the character, and here, its index. In the third example, I show that you don't have to use explicit typecast only with variables. It can be literals, constants, and even expressions. Here, I wrote some code that showed that you can use explicit typecast on a value any number of times. Just don't get confused. There is a compile time error here because we used explicit typecast with a check, and the compiler saw that we were trying to cast a double to a char, and since the double can have a fractional part, the information can be lost during the typecast. We rarely ever use explicit typecasting, but it does occur in programming, and now you know more about it. And this is the end of this lesson. Thank you for watching this video. I hope I helped you in some way. You can show your gratitude by liking this video, writing a comment under it, subscribing to the channel if you haven't already, becoming a sponsor of this channel, or donating to me via the link in the description. Goodbye.